Standard 8.G.1. This is the first standard dealing with geometric transformations, and this one is specifically about congruent figures and the fact that angles and line segments are also congruent in congruent figures. Parallel lines stay parallel. That doesn't change. So those are just some properties of congruent figures, that angles and line segments, they don't change their measures. Parallel lines stay parallel lines. So we're going to look at this problem number 2. It says, which of the following statements is true about the angles and side lengths in a figure when the figure is reflected over a horizontal line? Well, it's a congruent transformation, so the angles are going to stay the same, and the side lengths are also going to stay the same, so answer choice C. They both stay the same. Number 3, if triangle STU is reflected over a horizontal line, what's the length of side S prime U prime? Well, remember, side lengths stay the same. They don't change. These problems are very simple to answer because they do not change. It's all it's asking you is to recognize that. So side SU was 5 inches. So side S prime U prime is also 5 inches. In figure ABC, angle A has a measure of 60 degrees. What's the measure of angle A prime in figure A prime B prime C prime after a translation and a reflection? So these transformations just stay congruent. It doesn't change the size of the figure or the shape of the figure. So the measure of angle A prime is 60 degrees. And we know that because angle measures stay the same. Standard 8G2 focuses on congruent figures. It also includes combined transformations. So we're going to look at problem number 3. It says, describe a way to show triangle DEF is congruent to triangle D prime E prime F prime. And so the first thing I notice is that they're backwards of each other. So if I were to say draw a vertical line, then I could see that when I flip this triangle DEF across that vertical line, then I'm going to end up with a triangle DEF that's going to be somewhere about here on the other side of that vertical line. So it included a reflection across a vertical line, but we're not finished. It also goes down. So every coordinate, every corner goes down, and so it is also a translation down. Okay, so number 5, which sequence of transformations maps quadrilateral ABCD up here to quadrilateral EFGH up here? Okay, so one thing that you might notice is you would look at what points match up with each other. So point A maps to point E. Point B maps to point F. Remember, I'm just looking at the letters in order. So A to E, B goes to F, they're just the second letters. C goes to point G. and D goes to point H. And so what I can notice very quickly is that A and B went upside down to go to E and F. C and D went upside down to go to G and H. So it's upside down. Which means that when it went upside down, it's going to look something like this. And then it translated to the right. So we notice that there is a reflection across a horizontal line and a translation, answer choice C, because that upside down was a reflection. And it was across a horizontal line, for example, right here. Standard 8.G.1-4 focuses on the coordinates when doing geometric transformations. So we're going to look at problem number 2. It says, what is the rule that describes the translation that maps ALMN to L'M', So what happened to go from ALMN to the new triangle, L'M', N'? Well, we can look at each coordinate and say from M to M', it went to the right 5 units, and then it went up 2 units. So 5 units right and 2 units up. And what one coordinate does, they all have to do the same for it to remain congruent figures. So that works for every one of these. And you could test it and see. For N, it also went 5 right, 2 up. And for L, it goes 5 right and 2 up. So it works for every one of these. Number 4. Which one of the following statements is true about the coordinates of the points in a figure when the figure is reflected over the x-axis? So it's talking about whether their coordinates will stay the same or change. So I'm just going to go ahead and start with the rule. We know for reflection across the x-axis that we start with xy, and the x-coordinate stays the same and the y-coordinate changes its sign. Because when it flips across the x-axis, it changes its height. And so the x-coordinate's the same, but the y, the height, changes. So only the x values remain the same is correct. Number 6, the coordinates of the vertices of triangles CDE are given. The figure is rotated 90 degrees about the origin. Now, it should have been more specific. I'm going to go ahead and note this is 90 degrees counterclockwise. What are the vertices of the resulting image? Figure C', D', E'. Okay, so remember, a 90 degrees counterclockwise rotation. We know when we go 90 degrees that y and x swap places. And then if you ever get confused about which signs change, you could always sketch it out. I know that a counterclockwise rotation is where y changes the sign, so it's going to be negative y then x. But I could sketch it over here for a moment, and I could say, okay, I take a point, let's use this point 5, 2, and if I go counterclockwise, that's opposite of a clock. I was in quadrant 1, which has positive x, positive y. Now I'm in quadrant 2, that has negative x, positive y. And so I know that my first coordinate is going to have to be negative, so that was another way we could have determined that. So we have these points. C was at 3, negative 2, and D was at 5, 2, and E was at 7, 0. And we're going to do this transformation to get C prime, D prime, and E prime. So 90 degrees counterclockwise. I'm going to go ahead and list my coordinates for my what will be my x coordinate for all of these points first. So we start with the y coordinate and we change its sign and write it first. So I had -2. Now I have +2. We had +2 for the y. Now it's -2 for the x. Had 0 for the y. Still have 0 for the x because 0 doesn't hold a sign. It's neutral. Now looking at the original x's, they just stay the same. I did have 3 for x. Now I have 3 for y. Had 5 for x. Now I have 5 for y. Had 7 for x. Now I have 7 for y. And we've got the coordinates, or the vertices, of the resulting image C prime, D prime, E prime. Number 11, select all the sets of transformations that result in a congruent image when performed in any order. So, anytime we see a dilation, we can cross it off. And so I notice a dilation in this fourth choice and I cross it off. So the remaining choices are just congruent transformations. Standard 8.G.1-4 is just about some similar figures. We'll start with number 3. Is triangle ASTU similar to triangle SQR? Well, let's take one side at a time. ST to SQ. It goes from 6 to 12. But it looks like it's multiplying by 2. Then we have TU to QR. It goes from 3 to 6. Once again, we're multiplying by 2. Then we have SU to SR. It goes from 5 to 10. Once again, it's multiplying by 2. So yes, it's similar. An explanation, triangle STU is dilated by scale factor 2 to get triangle SQR. Number 4, select all true statements about an image after a dilation. The first one says the image is a different shape than the pre-image. That's not true. The shape stays the same. 2 says the image is a different size. That's true because they're similar but not congruent. 3 says the image has the same angle measures as the pre-image. That's true. Angle measures never change. 4 says the image has the same orientation, as in it didn't change by flipping, turning, or just translating. That's true. If it's just a dilation, it won't do those things. The 5th choice says this image is similar. That's true. And the last choice says the image has the same side lengths as the pre-image, and that's not true. The side lengths do change. Number 6, which sequence of transformations result in figures that are similar but not the same size? That means they are not congruent. So, the one that's not congruent is answer choice B because it includes a dilation, so it changed the size.